facilities. But where does the change to green thinking begin? The Recycled First policy. Recycled First will require transport infrastructure projects to optimise the use of Victorian recycled and reused materials. This will see the use of recycled aggregates, glass, plastic, timber, steel, ballast, crushed brick, crumb rubber and reclaimed asphalt pavement take precedence over virgin materials. For information, technical advice and support on bringing your sustainable project innovations to life, drop ecologiQ a line. Recycled First, supporting purposely greener infrastructure.
Good morning, everyone, and welcome to our December Innovation Showcase, the last for 2023. My name is Doy Lee. I'm the Industry Manager with ecologiQ, and I'll be your host for today. And my co-pilot is Lauren Rowett, Industry Support Officer. So in the unlikely event that anything happens to me and my internet, Lauren can at least take over and continue today's showcase presentations. I'd like to kick off by acknowledging, although we're meeting virtually, that we still meet on traditional lands. So for me, I'm dialing in from the lands of the Bunurong people of the Eastern Kulin Nations. I'd like to acknowledge their elders past, present and emerging, and any Aboriginal or First Nations people that we might have with us on our showcase event today. So I'd also like to acknowledge and thank all our sponsors and partners and presenters and panelists that have come along to today's event. So we've been running the showcase for about coming up to 2.5 years now. And in that time, we've launched many new innovative products and that have come onto the market. And so the idea behind this really is to share information, give our manufacturers a platform to get some feedback and get the word out about their latest and greatest innovations. And also and provide an opportunity for you in the audience to find out more as well. So after this, this session is being recorded, and we'll share the presentation slides and we'll post this recording on YouTube. So if you didn't catch it today, you could still share this with your colleagues and catch up with it later on. So just a little bit about ecologiQ if you haven't heard of us before. So ecologiQ is a Victorian Government program to roll out, which is now, I no longer call it a new policy, but it is still remains Australia's first Recycle First policy. So what that means is for the Victorian Government, as part of our transition to that circular economy and moving towards that low carbon, more sustainable future, we do need to acknowledge that here in Victoria, we still have significant waste stockpiles of plastics, glass, rubber, construction demolition waste and other things that sort of are filling up our landfills. So the policy has been in place since March 2020, and it's been also adopted by the Department of Transport and Planning as well. But it means that for any projects, any big build projects here in the state, so your major road projects, your Northeast Link projects, the future suburban rail loop, all these contracts now come with a Recycle First requirement. So those projects are required to optimize and find the best use of recycled materials on their projects as possible. We're not leaving it up to just our project and contract partners to do all the heavy lifting. So the ecologiQ team is there to support and scaffold that. So whether that's through our delivery and implementation team, who work very closely with projects from procurement into delivery to help you get those materials into your projects. Our technical work around updating standards and specifications. So we work very closely with our colleagues at the Department of Transport and Planning, Metro Trains and V-Line and other asset owners to update standards and specs and bring in new materials into them, into the specifications. And Lauren and myself look after market development and supply chain. So obviously we're here to support businesses like some of those that are presenting here today with bringing their innovations to market. And really importantly, like all good change programs, if you don't get the storytelling, get the word out, no one will know about it. So we have a really strong comms component, and we'll go through some of the resources and some of the material that they've published to help educate and raise awareness and build capability for those looking to get involved in that circular economy transition. So. And just to date, I can't remember how many MCGs this was, but I know that last time I checked, we have over 50 major transport projects that have recycled first requirements within those contracts. So with those committed levels, they're estimating almost 3.5 million tons of recycled materials will be used up by those projects. And to date, we've used over 2.5 million, which I think I was told is at least one MCG for those in Victoria. Very important metric. So. I'd like to now introduce our panel. So we've assembled a couple of experts to help us provide feedback today to our presenters. Without further delay, Andrew Peppercostas has been on the panel since day one of our showcase series, probably 2.5 years ago. Andrew, would you like to say hello and introduce yourself to the audience?
Thanks, Dwayne. Good morning, everyone. Andrew Papakostas with the Department of Transport Planning. My role is Principal Engineer, Pavements and Materials. Part of that role deals with specifications and standards, and also looking at innovative products as presented to us by industry, and in my area, particularly in the pavement technology space. And as always, looking forward to today's session. Thanks, Dwayne.
Thank you, Andrew. Next, Irina Kriteska, Deputy Director Engineering with Major Road Projects Victoria.
Thanks, Zoe. And good morning, everyone. My role, and together with the engineering team, we provide technical support and expertise, I guess, in all engineering disciplines that help, I guess, deliver the infrastructure projects. We're particularly involved in working on updating the standards, changing, and even creating new specifications and standards that promote, I guess, the use of recycled materials and innovative materials and products on infrastructure projects. So yes, I'm looking forward to the presentations. Thank you.
Thanks, Irina. And last but not least, Numan Sheriff, stepping in for Kerry Gagousas, our resident rail panelist, but who's unable to join today. But Numan, please tell us all about what you do at
Morning
RPB.
all. I'm Sharif here. So I work with Rail Projects Victoria. I'm the Senior Sustainability Advisor. RPB is currently delivering projects in the regional areas such as your Murray Basin, Shepparton, Gippsland, Warrnambool line upgrades, and we've got the Metro Tunnel project as well. In my role, I'm working closely with a lot of our delivery partners as well as organizations such as ecologiQ to collaborate and essentially promote the use of innovative and recycled materials on our projects. So keen to hear from everyone. Thank you.
Fantastic. And thanks, Numan, for stepping in as well. And again, these are all recorded on YouTube, so you can hop onto the ecologiQ channel and find previous showcases there. So just a bit of a call out to the audience here. So I think having a policy is half the work. The other important work when it comes to seeing genuine outcomes and adoption and moving towards that circular economy is to collaborate. So my call out to those in the audience here today, I know we've had over 200 people register for this event. We have councils, other government departments, interstate and local. We have consultancies, construction contractors, universities. So everyone under the sun who's involved in the ecosystem when it comes to pushing and delivering change. So my call out is that if you're an asset owner, you're in the construction space, you're in urban design, or you're a manufacturer, to please reach out to us, because if any of the three products that are presented here today, you see a potential opportunity on your project, we see every project as a potential catalyst for change. So you don't need to be working on a big build project. I don't mind if you're working on a council resurfacing work somewhere, or you're working on a project for another department. It could be for in the built environment, homes or housing, or even boating. It doesn't matter. Every project is a potential catalyst for change. So please encourage people in the audience to reach out to us if any of these materials that are being presented resonate and you see possibility in your work. So just a little bit of some highlights. Since we've been running this showcase and ecologiQ's been about, through this series, we've been able to trial and bring 9 new products into the market. We've updated 4 standards to include recycled plastic noise walls, recycled conduit pipes and other things. And our team here with Irina and other colleagues have actually written 3 new technical standards from scratch. So we recently were really proud to pick up the Industry Leader in Circular Economy Innovation Award and the Premier Sustainability Award. But I think that's just the start of the work, because the last 3 years, those are some of our wins to date. And that's a photo of myself and a former colleague out on site at a trial of recovered carbon black going into the roads. Again, that was a product that was pitched here on the showcase, and then 6 months later, it went into the road. So if that performs over the next few years, our specs will be updated so you can include that in your asphalt. So and that's a material that comes from end-of-life tires, which is one of our most persistent and problematic waste streams. And if you caught the some of the data that came out from that from Tyre Stewardship Australia recently, Australia's actually gone backwards in the last year with how we're using end-of-life tyres. So a really important piece of work. My last call out to people in the audience is if you already don't have access to please sign up and jump onto our Knowledge Hub, because all the information that we have, all our knowledge is actually encapsulated there. So from visual guides to supplier maps that help you find suppliers and manufacturers of recycled materials, we have reference guides that collect and provide a one-stop shop of the standards and specs here in Victoria that let you use recycled materials. And we have a huge library of educational videos, mythbusters, case studies, animations and guidelines. And also we've recorded our 2 previous conferences. So if you haven't been to the ecologiQ conference before, keep an eye on that and for the future ones. But you can also go back and view all the presentations and learnings from the previous conferences. So just drop us a line at ecologiq@roadprojects.vic.gov.au. And one call out on our Knowledge Hub, we do have a new resource there, which is an innovation database. So all the products that have been pitched through the showcase series are now sitting on our database on our Knowledge Hub. So you can go in there and have a look at all the previous innovations. So you can see that you can have asphalt made with coffee cup through to recycled plastic sleepers, geopolymer concrete that's used for in curved surfaces. I think there's over 50 entries there on our Knowledge Hub in our innovation database. So again, I encourage you after this, if you were inspired by any of today's presentations, jump on our Knowledge Hub, get stuck into some of the information there and have a fossick and have a look around our database. And if any of these, again, innovations, you see an opportunity on your project in your line of work, then it's there as a resource for you to reach out. So now, moving into the main event, just a bit of housekeeping about today's showcase. So I will now field 3 presentations from 3 different businesses. So you'll know this is a webinar in the audience. You won't be able to turn your videos and mic on, but you can ask questions. So that there's a Q&A button on your Zoom taskbar. If you have any questions for our presenters, please drop them in during the presentation, and our presenters can come and answer those after they finish presenting. So we'll kick off this morning with Riley Aiken from Apparel to tell us all about UPtex before moving over to hear from Depender. We'll talk about Elixum and Solarcrete. And lastly, Darcy Rogers dialing all the way from New Zealand with Downer talking about their BioBine in bitumen. So we'll try and keep it to 10 minutes to present and 10 minutes for our panelists to ask our presenters any questions that they may have. Without further delay, Riley, I'll have you come onto the virtual stage and tell us all about UPtex, and just tell me when you want me to hop onto the next slide. Over to you.
Excellent. Thanks, Doi. So yeah, I'm Riley Aiken, Partnerships and UPtex Manager at Apparel. Today pitching UPtex, Apparel's revolutionary, incredibly versatile and entirely recyclable panel made from 100% post-consumer textile waste. Next slide, please, Doi. So before I tell you about UPtex, I want to explain Apparel's mission and why UPtex was created. While our base of operations is in Australia, Apparel's mission is to eradicate textile waste globally. Our transparent, traceable onshore textile recovery and recycling process has made us the #1 choice for numerous big build projects, hundreds of organisations, government organisations, councils, brands, retailers, and everyday Australians trying to divert their textile waste from landfill. We created UPtex to further improve our scalability and to keep textiles in circulation as a high-value product with limitless applications. Next slide, please, Doi. Unfortunately, I don't have an MCG conversion formula for this, but we've diverted over 10 million textile items from landfill across Australia and New Zealand through our rigorous process and our fantastic partners who support Apparel's reuse channels, which assists over 450 charities nationwide. While some textiles can be reused, the majority cannot. This could be because they're uniforms, which cannot be recirculated to the general public for brand security or licensing reasons, or simply because the garment has reached its end of life. After all, no one wants to wear a ratty t-shirt full of holes, so this is where UPtex comes in. Next slide, please, Doi. UPtex is made from 100% post-consumer textile waste, including polyester, cotton, high-vis, and many other materials that would otherwise remain waste due to a lack of recycling channels in Australia. Not only is UPtex made from recycled textiles, it is also completely recyclable at end of life. Apparel has committed to recycling all UPtex free of charge at end of life to ensure these high-value materials remain in circulation for as long as possible. In the next few slides, I'll show you a few of the products our team has made with UPtex over the past few months. This is only just scratching the surface. Everyone that gets their hands on UPtex comes up with new and innovative ways to utilize it in their industry, and thanks to our sorting process, UPtex retains the best qualities of its input materials, ensuring its outdoor durability and strength over time, regardless of application. Next slide, please, Doi. As mentioned earlier, UPtex is manufactured from a range of materials, including natural fibers like cotton and wool, as well as synthetics such as polyester, elastane, nylon, and more. This blend gives UPtex the desirable qualities of all input materials and ensures its longevity, regardless of if it's used indoors or out. Due to the versatility of UPtex and range of input materials, it is best to engage us early in the stages of your project, such as during the initial design phase, so that we can ensure that our manufactured panels best suit your application. As a recycled product, the color of UPtex does vary from batch to batch. However, with sufficient volume, we can control the final color. For example, if a business that outputs their employees in red polos wanted to use UPtex, we could utilize those polos at end of life to create a batch that will match their color scheme straight out of the gate. No printing required. Don't worry though, UPtex can also be printed after manufacturing to match brand colors or more, as you'll see in the next slide. Next slide, please, Doi. Thank you. Though UPtex is a new product, it can readily fit within existing print workflows and processes without needing to reinvent the wheel. UPtex can be used to create wayfinding, event or promotional signage, hoardings, or even printed consumer products. In addition to unprinted or raw UPtex, Apparel has a capability to deliver printed, finished signage if required. The next slide will demonstrate UPtex's benefits in comparison to standard print materials. To the best of our knowledge, no rigid signage product on the market is made from 100% recycled materials while also being easily recyclable at end of life. Nor can the color of any other board be completely customized like UPtex. UPtex ticks the box for just about every signage application while maintaining its recyclability. But the uses don't stop there, as UPtex can also be used in a range of packaging applications, as you'll see in the next slide. Through our experimentation, we've created tote bags, gift boxes, shelving, protective 3D box inserts, wine boxes, and wine racks that all perform as well, if not better, than their mainstream counterparts. And just like UPtex's excellent print compatibility, it is also compatible with a range of cutting technologies, including CO2 laser cutting, flatbed cutting, die cutting, and scoring, to suit your existing processes while also being easily folded, stitched, or slit to create custom 3D shapes. We have more examples of prototypes in the next slide. The examples pictured here are just some of the ideas that our team has come up with in the weeks leading up to UPtex's launch. There's plenty more applications, both commercial and consumer, that we simply haven't encountered yet. And as mentioned earlier, the more industries that engage with us and the more eyes and hands we have on UPtex, the more textile waste we can divert from landfill as additional applications are uncovered and developed. Next slide, please, Doi. So UPtex is available in 600 by 1200 and 1200 by 2400 millimeter panels as standard, though we can manufacture specific sizes to suit your needs. It is also available in a variety of thicknesses or gauges, including 3, 5, 10, 20, and 24 millimeters in a range of densities. We can, of course, produce custom densities and gauges to suit your project requirements, as you may have seen in that last slide and behind me somewhere. The wine bottle packaging was a lot thicker than 24 millimeters, and this was achieved by layering 10 millimeter UPtex panels together, compressing them, and then CO2 laser cutting to shape to create a much thicker panel than our maximum manufacture size. Next slide, please. So pricing is listed here as a guide, with per unit pricing reducing with volume. However, we can also quote based on project requirements and scope. So this is just to give you a guide. It is available on our website as well. Next slide, please, Doi. UPtex has already received an NRC or acoustic rating of 0.75, meaning that when properly installed, 75% of sound is absorbed by the panel rather than being reflected, making UPtex perfect for office, retail, and residential environments as sustainable acoustic paneling or blades, desk dividers, and even whole desk units to improve the comfort of inhabitants. We are in the process of fire testing UPtex, with testing to be completed early next year. On top of our material certifications, Apparel is also a certified B Corporation, having passed a rigorous audit process to be recognised as an inclusive, equitable, and regenerative organisation. Next slide, please, Doi. Once we have completed our fire testing in early 2024, the possibilities for UPtex expand even further, enabling it to be used as recyclable ceiling tiles, fixed and internal acoustic panelling, wall fixtures, and potentially even as part of next generation public transport infrastructure. As a circular example, we're currently working with Revert Group to take polyester insulation out of an office decom they're working through before converting that insulation into UPtex and then reintroducing that UPtex as desk dividers into the new fit out. This is only the beginning. Next slide, please, Doi. If you'd like to use UPtex, it's imperative that you engage us in the early stages of your project, such as the design phase, so that designers and engineers can understand and spec this sustainable alternative to traditional materials, and so that we can deliver UPtex that is suited to your needs. More UPtex in circulation means less textile waste going to landfill, so please get in contact via our website so we can work together on your next project and support the circular economy. Thank you, Doi. And thank you everyone else for listening.
Thank you, Riley. I'll now invite our panelists to switch their cameras on. And Irina, since you're the fastest, I'll let you open. First questions
Thanks,
from Irina.
Look, it's a great to see that we can utilize finally the waste, the textile waste, to do something good with it. I mean, my first question would be: do you see any obstacles, I guess, that prevent you to kind of utilize this product and launch it out there, or is it another market that you're looking at, or kind of like I said, some limitations that you see that we can help you with? The other thing is, I understand the fire rating or the fire resistance, I guess, is tested, and that's obviously a very big and important test, because it might determine if you can use it in building industry and everywhere else, because I can see a lot of use of this with cladding and kind of partitions and stuff like that. I'm not quite sure in which part of the infrastructure, or should I say big build, I guess, projects this can be utilized, but certainly signage and kind of temporary works and other things might be a bit of opportunity there. So maybe you can tell us which area do you think you got I guess a bit of you need a bit of help, or you have some obstacles to continue.
So thank you. Our greatest obstacle at the moment is the fact that it's not yet been fire rated. Honestly, a lot of projects won't even look at the product unless it's got that tick, which is completely understandable. So once we have that tick of approval and we've got that rating, I think it'll open the doors for a lot of things. The reason that I put so much emphasis on signage and packaging in this presentation is because those are applications that we can just go straight away. You don't need to fire rate a hoarding, for example. It can just go up. So yeah, the biggest obstacle at the moment for us is just fire rating, and then from there it will be getting into the hands of engineers, so that they can understand the product, get familiar with it, and spec it for a project rather than just relying on mainstream materials.
One more question. I assume you have done some testing on various stuff, because obviously there's so many parameters that you have to kind of confirm, and the properties of the material, the strength and everything else that obviously you need to kind of then utilize to determine thicknesses and stuff like that. But how do you control, I guess, the properties based on the input material? Because I understand there's so many different kind of type of textiles.
Correct.
So have you tested if, let's say, use more polyester type kind of textile versus cotton or wool? What is the difference, and how do you control that, or how do you plan to control it in the future?
So the way we control it is through our standard recycling process. So whether it's being turned into UPtex or any other products, our sorting process takes care of separating materials into different streams. The majority of UPtex is cotton and polyester. There is a percentage of other materials in there. but we've found that there is a level of cotton and polyester that we need to put in there to maintain consistency in the strength and performance of it. But really, it'll be testing as time goes on, as we find new applications for it. I can't think of one off the top of my head, but maybe there would be an application that would lend itself to having more high-vis or PPE in it, something like that. So the control is simply down to our warehouse team, who do a fantastic job of separating out and identifying materials, and then our manufacturing team who work on that magic blend to go into it.
All right, though this sounds like another specification that needs to be written, you know, for.
Yes, it would be. It would be. Yeah. So
Potentially.
and to be very clear, we do track. It's not just okay. We'll put whatever we have on hand into the UPtex. We do track what percentage is cotton, what percentage is polyester, what percentage is nylon, so that we can have that consistency within the batches.
Yeah, that's great. Thank you, Riley.
It's okay. Thank you.
Thanks, Irina. I think Numan was quicker to the trigger.
Yeah,
sure. Numan.
Sure, I'll ask some questions, and there's some good ones in the Q&A as well. And one of the areas quite interesting. So I think again on the properties of it, specifically with regards to water resistance and UV. And then secondly, again, as Irene mentioned as well, the different compositions and the research and development part of this, I believe in these early stages would be a focus for the company.
Yeah, correct.
So especially with, the fire testing as well, that's something quite significant as you've already identified. But with other properties such as, things like how compressible it is, how easily it gets deformed, water resistance, UV, even things like pest, the insects, etc., that kind of impact. So any thing you can expand on over there?
I don't have any concrete results that I can share regarding moisture, UV, or pest resistance,
okay.
But that will go into our data sheet when it's all together. We're still pulling all the information together.
And any tentative timeline as to when that'll happen?
It would be Q1 2024.
All right. Thank you.
Thank you.
Thanks, Numan. Andrew.
My questions have been answered, but Riley, just one observation. Often when we've got these new products being proposed and assessed, one of the things that we look to is back to the supplier to say, well, what systems have you got in place to ensure the client receives the product that's been tested and endorsed as the product they actually get, not just tomorrow, but 6 months down the track, a year down the track. So we turn to your quality systems and look for them to be in place and for you to quality assure your product. So just a comment for information, Riley. But thank you.
Thank you very much.
Thank you. There's no other questions for the panelists. Thank you. Look, I've had the fortune of visiting the apparel factory, and for me, just to allay any concerns, the fabrics that are being used to make UPtex really are the textiles that have no other options. So I was astounded by the scale and the volume of textiles coming in. So whether it's outdated uniforms, beanies, scarves from competitions, everything you name in between. But here at ecologiQ, we obviously that work towards a circular economy, avoiding and reusing the highest priorities. But we are really dealing with the sort of the textiles that have no other options at the moment to be turned into UPtex. So
thank you, Doi.
Not a problem. There's no other questions. Riley, I think there's some questions for you in the Q&A, so feel free to hop into the Zoom chat and answer some of those queries. I'll now invite Dipender Malik from Alexum to come and tell us all about Australia's first and maybe the world's first concrete.
I would say world's first. So
world's first from solar panels. So,
yeah, good morning, everyone. Good morning, everyone. Thanks, Doi and team, to put us on this panel to present something about Alexum. And so this is the first, we've just made this presentation for Australia. This is the first solar panel recycling plant out in Australia, but I think it is going to be the world's first solar panel upcycling. I would say not recycling, because whatever we're going to be recycling, we're going to be reusing the material out of the end of life or any damaged panels. Next slide, please. So this is our the roadmap for Elixum. So right now we've got the first plant which is coming up in Kilmeny, which is going to be an R&D and an innovation center. But we are already in the process of finalizing land and at few other states so that we can have a better network of collecting all the end of life and damaged panels, so that can be reprocessed and the material can be used in a better way and can be a part of the sustainability and a circular economy. Yep. So these are the proposed location wherein the plants are going to come in. Next slide, please. So this is our main Victorian plant, which is our R&D center as well, and it's an Australian headquarter as well. This is based at Kilmeny, and if you see these pictures, this is a $3 million facility which we are putting together at the site, wherein we're gonna process most of the panels which are coming from Victoria. So if you see in the background, there are a couple of pictures which are showing you it is the big blue machine is a vortex system, wherein if we put in the solar panels, it works on a technology which is a pressure, shockwave, and cavitation process, wherein disintegrating the glass which is on the solar panels into a fine grade glass grade sand, which could be used in concrete production or even the pre-mix concrete plant, which is so if you see, this is the first part of our plant, but then in the coming months we are putting up our own dry mixing batching plant as well, which will be producing a pre-mix concrete bags for the community as well. Next slide, please. In the whole journey for Elixum, we have been partnered with RMIT as well as University of Melbourne, those who have done our initial testing for the product and for the whatever, and also for the concrete mixes to be what we should be running through. And during this process of putting up the plant and everything, the whole process is around creating few local jobs as well, because the region which we have been marked to put up the plant is the same region wherein all the thermal power plants are coming down, and we can get a lot of people, those who have worked around those plants, and we are trying to re-employ them into our business, and we want to train them, all those people, to be coming up and be a part of the Elixum journey. Yeah. Next slide, please. So this is the journey of Elixum or OGES. So OGES is our parent company, which we started in 2008, and we have been working in supplying a lot of cables to a lot of solar farms and a lot of our own, like wherever the big built and all those projects as well. We have been supplying cables, and we tend to have our own NATA accredited cab lab as well, which is the only lab in Australia which can do a high voltage testing as well. When we were doing all these solar farms installation, we came to know, we saw there was a lot of panels which were getting damaged while they were being installed. So what to come up with and how to do it. So the whole, the idea came in from 2020, and ever since we've been working around this. So how to use these panels rather than going into the landfill, we should be using it in a better way. So this is how we partnered with RMIT and University of Melbourne, and we started this journey in 2020. And 1st of September, we've already installed our first plant, which is in Kilmeny. Yep. Next slide, please. So currently, like, there are about 100 million solar panels in Australia, which, like the slide tells you, pushing to net zero requirement additional 1900 gigawatts of solar energy. This equates to almost about 2.7 billion PV panels required. Forecast as per our study, it tells about 450,000 tons. That is equates to 15 million panels of solar waste by 2040, which would be a part of end of life, as well as some damages or weather condition which can cause a damage to the solar panel as well. Yeah. So there is nothing at this stage which has been done for end of life solar panels or any damaged panel. Most of them used to go to the landfills, or they were only used to take out the aluminium which forms the frame of the solar panel. But the rest of this thing was just stored in any part in containers or in any warehouses. Yeah. Next slide, please. So this is what we call it upcycling, a new kind of mining. So if you see the screen, it's self-explanatory. We get damaged panel while installation. We get damaged panel because of weather. And the third part that forms our the raw stock feed would be end of life panels. An average lifespan for a solar panel is about 17 years. Yeah. And then, so how Elexem comes in is we will be having a national wide collection points in every state. And then we will be transporting all those panels to various locations where we can upcycle, out of which pins and will, and only the Kilmeny side, Victorian side, would have a dry mixing batching plant wherein we could be producing that Solarcrete as a bag product for the community as well. Next slide, please. So this is what a solar panel is made up of. Yeah. So which can consist of a aluminum frame, a tapered glass, an EVA solar cells, an EVA at the back, and the back sheet on a junction box. Like average solar panel weights about say 32 kgs, out of which 70 to 80% is glass, and rest is the rest of the materials. So at this stage, in stage 1 for the plant, we can take out the frames through the deframers, and the whole aluminum frames can be sent for metal recycling. And then 70 to 80% of that solar panels, which will be ran through the vortex system, we can take out the glass out of it. At this stage, we are in process and in an R&D process with the RMIT, wherein we are looking for a chemical separation process for the solar panel, wherein you're going to dip the solar panel into a ionic liquid, wherein the glass would be just differentiated from the panel, and we can run this glass through the vortex system where it will be converted into glass grade sand, and then the rest of the material would be through the chemical process. We can take out copper, silver, and which will be a high valued item, silicon, out of the panels as well. At this stage, and we are most probably will be in years time, we'll be having a second warehouse at the same facility, which we can start the commercial process in there as well. Next slide, please. So this is like, it's like I told you, it's going to be recovery of silicon for reuse, and copper and silver, which are high valued item, and recovery of aluminum and glass is currently which we'll be processing at our facility. Next slide. And then there is because we are having a lot of contracts coming through the solar farms and everything, this is the whole process around the e-waste, wherein we've got a waste management policy. We would have scan of each and every panel which is coming through the gate and what has been done with it. And then we would have a solid quality assurance that whichever panels which are coming from various solar farms or end of life, what they are not ending up in a landfill, rather what have been the use of it and how we will be using it. So that's the whole waste management policy which will be coming up for Elexem and which is already in place. So yep. Next slide, please. At this stage, we are already in long-term contracts with few suppliers, which would be like the big solar farm installers. Like you can see few big names underneath the slide. We are also coming up with a solar credit program wherein people can come down and put up their solar panels and they can have credits in lieu, which they can buy the product, or if they want to buy even the dry packed for concrete as well, they can do so. And then we will be having the full custody reporting for EPA requirement for any big project, how much panels have been received and how they have been recycled and how the material has been used. Next slide. And the first part is like we at the facility right now as well, we test each and every panel which comes through the gate, whether it could be reused. So you can see these pictures right now when we are processing and we are looking into the panels, whichever the good panels are, we are already installing at our site to have our own power generation and through a small solar farm installed at the site. Next slide, please. This is the team involved in the whole journey for Elexem, which has started from 2020 to 2023. Yeah. Next slide. Yep. Thank you.
Thank you, Dipender. Yeah, I'll open up with Numan. I think fastest there.
Thank you. I want to hijack this conversation with the question and answers, but a couple of things, Dipender. Thank you first for presenting. Yeah. Now, solar panels are, of course, a piece of technology, and there will be technological updates that will be happening.
Yes.
And
yes.
you've only got, assuming that, for the next 5-10 years or whatever time period, you've got the supply of existing solar panels available in the market, which have been used on projects, etc.
Yeah.
So one thing to think of is, of course, the future proofing of your company essentially and the products that you'll be able to produce. The other thing which I'd like to mention is also that what we've experienced with a lot of infrastructure projects is that if they are in regional areas, then the supply of such products typically becomes an issue because of the distance. And it so happens that if you're, saving on one aspect, then the transportation costs are too high, or your, carbon emissions because of transport is too high. Hence, the product doesn't be feasible anymore as well. So that's just another food for thought as well, to strategically place your manufacturing facilities in places where you have that pipeline of projects essentially.
Yeah, so like it's a good question. So that's why, like I showed in my slides as well, that it is just not that we are confined to one facility, which is in Victoria, but we are trying to have the facility in almost every state so that it's a less lead time to get the raw material and to process as well. At this stage, looking into what we believe is the enormous supply for this end of life panels would be around 2025. So that's why we've still got 2 years. So right now we're keeping our majority of the panels at Victorian site so that we can process them. Yeah. And it will be a business model depending on what's the availability, how we are placed. And also it is going to be how the demand is. If we can get a sort of that chemical separation process, which is really successful in a lab, then it is just matter of dipping a solar panel, you can eradicate, and then you can travel. The material would be like handled a little bit easier than compared to handling a 35 kg panel right now.
All right, thank you.
Yeah, and just to add this as well, so we've already got one more like DA approvals at Casino in New South Wales. It's a border of New South Wales and Queensland, so that would be the second plant which we'll be hearing in a couple of months. So yeah.
And my understanding, so I had the fortune of going to the launch for the product and seeing Professor Elias at RMIT, who I understand came up with a patented process for separating the panels.
Yeah.
But the reason for Kilmarnie is, one, that's where most of the panels are coming offline anyway. So your damaged panels are there's a lot of solar farms coming up in the region. And
yes.
And secondly, I think sometimes overlooked in the sustainability space, but that social value of job creation. So the Gippsland Valley is an area that has been, economically pretty
it's been hit hard, like with all this.
So yeah.
So the whole idea of the plan to be put in there was to help the community as well. And then with all the power plants and everything which are closing down, they are coming up. And then if you can utilize that workforce which already know about power generation and everything, and helping a project to be already starting from scratch, and they are part of it. It's a community build up program as well. And we are even at Kilmarnie, we are placed very correctly because we are next to the landfill. So probably even in down the time, if we say, all right, we're going to run some program wherein we will have our bin collection points at each and every council as well. It is all in the process. But again, the flux of the raw feed, which will be end of life or damaged panel, will be coming from 2025. So we've still got that time frame. I'll just give you a side view example. Like the most of the panel which are lying at our site right now, which we need to recycle, there are about 70 to 80,000 panel which were just damaged from one hailstorm in Queensland. So you can see the number, how it comes in, and roughly. So if you see, like I was telling in my slide as well, that one solar panel, which is about 32 kgs weighing up with aluminum frame and rest of the stuff, I can produce out of 25 to 30 kg of sand, which is coming out of that one solar panel, depending on the size as well. They're all different. Like some of them are big, some of them are smaller, but average 20 to 25 kg of sand from each panel.
Thanks, Dipendo. Andrew.
Well done, Dipendo. That's really interesting work, and congratulations on innovations. So with respect to the glass, you're proposing to use the glass as a component in concrete. That's the work that RMIT did for you?
Yes. So it will be a replacement, like a percentage replacement with the trials, which I can share that report as well, but it's a little bit more technical. I can put it on to die, and then you guys can look into it. They've done some initial trials replacing sand from 20, 40, 50 and 80%, which they have seen, and it's really successful as per as the strength and the normal stuff is. but we still need to do a lot of R&D behind the, like when we talk about the structural concrete, which is like Vic Roads and specs, there will be a lot of more studies need to be done. But yeah, we are already in talk with some industrial partners wherein we can start doing those initial trial in Q1.
Yeah. So we currently allow predominantly glass derived from container glass waste into asphalt and concrete in non-structural concrete. One of the challenges we have, particularly in the concrete space, is contamination.
Yes.
Is your product essentially a clean product?
Yes, so it's going to be a high premium glass which is used on solar panels. So like your question is good. Like it's all about roadside glass. The majority of the glass is like it will have sugar into it, which will be detrimental for concrete. Will not go, means it will retard the concrete. But our product is just the panels on the roof. So there is nothing. There's no sort of contamination into it, and then means like it's an advantage if you push the ratios, then you can cut down on the cement level to have that similar strength of concrete.
Yeah, and there's no coating on the glass itself.
Yes.
Right. Okay. So essentially, the process issues around contamination.
There is no contamination here. It's a clean glass. There is no clay. There is nothing. So you can definitely reduce that. If you want to reduce your carbon footprint by reducing the cementitious used in the concrete as well, that would help in that process as well.
Well, I think just for your information, there is a national specification in relation to the use of recycled glass in various infrastructure applications. So it might give you a bit of an idea of what road agencies and road builders, etc., would be looking for from a performance with respect to glass in concrete and other applications. So, well done on the work.
Yeah, no, thank you. Thanks a lot. Yeah.
Thank you, Andrew. Irina.
Thanks for the presentation. It was great, and of course, there's a great use, I guess, for the recycled glass and sand and new materials. And as Andrew mentioned, I guess standards are clear in terms of what needs to be. I guess what you need to comply with in terms of the material, and it looks like you've done a great job, in involving RMIT or universities to kind of do some testing and research.
Yes.
And you already comply with Australian standards, some of those Australian standards. So I guess before you launch into kind of full production, those things will be clarified if there is any unknowns. So I'll just ask a question more around capacity and cost, because obviously having capacity will determine what type of projects or clients you're going to supply to.
Yes.
And it's early to say that, I guess, in terms of building capacity by 2025. But in terms of the cost, what is your expectation? Would you be competitive then with other similar kind of facilities when you offer the product at the end?
Yes, definitely we have to be. If we have to survive in the market, we have to work around those numbers. Yeah, that is one thing. But secondly, like your question means like regarding the raw feed as well. So at this stage, the plant is designed just to do the recycling of the solar panels. But in coming month, we are trying to redesign another feed into the vortex system wherein we can process the roadside curb glass as well. Yeah. So that is something is right now going ahead. So probably by next week in the blue machine, which Big Vortex have shown you, we will be having a 2 type of feed. So one part which would be coming to the warehouse, which would be a solar panel glass. And then secondary part would be, we will be trying to reprocess the glass cutouts or even the roadside curb glass and do that testing against that as well. If in case, then we can see how the value comes in for what material, and then we can price it accordingly.
Do you then plan to have other plants elsewhere, I guess, through Victoria? Because obviously transport is a big factor into the cost as well. Yeah.
Yeah, we would love to have plant in every state. That's the whole plan right now. Yeah. So at this stage, like I told you in my presentation as well, so casino at New South Wales has already been approved. Yep. So we are already talking in Western Australia as well. And like every state we are talking. So in coming 6 months, we believe that we would have land allotted to us in every state.
Yeah. Okay. I mean, when I see more plants, I would say in Victoria, because, you know, having a plant closer to the metropolitan area versus in regional, it may be two different things, you know, like, because it depends
no.
where the
So
yeah.
yeah, definitely it is. But again, like if you discuss about the sand belt as well, the most of the sand belt right now coming through to any big project in Victoria or Melbourne, I would say, is through Gippsland or Bacchus Marsh. So that's the same lead time for us as well. But at this plant facility, we would be even trying to have a bag product as well. So like as we are bagging the concrete, dry mix concrete, we would be bagging small like glass grade bags as well, which can be just thrown at the back of the truck and to cut down that cost of transportation moving forward. And with limited designs of the concrete plant, which you see around especially around Melbourne, where there's not any scope to put in a special bin for a special sand. So we would be coming up with a bag product as well.
Okay, that's great. Thanks a lot. No other questions.
Thank you. Yeah.
Thank you, Irina. And with that bag product, so will we be seeing Solarcrete at Bunnings in 2026 and beyond, Depender?
No, maybe before that, we're trying to 2024. So
Okay.
no, it will be 2024. You'll be able to see the bags. So the plant would start, means the concrete plant would be started installing in first quarter of 2024. And within 3 months, we'll be able to install the plant, what we reckon. In the meantime, we will have the glass grade on the ground as well. And like I've spoken in my presentation as well, we are speaking to a lot of industrial partner. In the meantime, we'll start that testing for the glass grade sand to be used in any sort of means. We know it's non-structural concrete, it's not an issue. You can push it to 30 to 40% or even 50%. But yeah, it's more about the structural concrete, wherein we try to see if it has got, if we can have a replacement in a Vic Road mix, that would be good. And then tick boxes for all the big projects, isn't it?
Yeah, absolutely. Well, on standby, we have a pipeline of projects here to help with those trials.
Yeah,
Yeah.
All right.
I was going to say thank you. We've got 4 questions for you in the Q&A. We're going to hop into there, starting, I think, with April Williams, and some great questions there around your manufacturing processes and whatnot. So please hop in and answer those questions, and we'll have our next presenter. Thank you.
Thanks for the opportunity. Thank you.
Pleasure. Thank you. And now I'd like to introduce Darcy Roger. Darcy from Downer, please tell us all about BioBind. Over to you.
Thanks, Dorian. Appreciate you having me on as well. So today I'm going to be talking about BioBind, our renewable bitumen replacement. And everything I show you today, even though I'm presenting from New Zealand, our road science brand within Downer is responsible for developing and implementing new technology. So everything you see today, we can make available in Australia as well. Next slide, Dorian.
Nope, there we go.
So if you look at the current situation, obviously one of our major building materials in terms of road surfacing is obviously bitumen, and it's distilled from crude oil. This equates to about, across Australasia, equates to about 430,000 tonnes of embedded carbon produced through use of bitumen. So it's quite a big number. And there's currently no viable alternatives. And I guess the thing that's really driving this for us is if you think about how much the oil reserves are left available to us at the moment, and most people are kind of predicting they'll run out in about the next 50 years. And I'm sure being human beings, we'll be able to find other ways to extract more out of the earth. But, with that comes a cost as well. So, and if you combine that with thinking about how, I guess, our surfacing life cycle, most of our surfaces last anywhere from 7 to 14 years. It's quite a long development cycle. So for us to evaluate this technology or anything new, it does take some time to prove it works just as well as what we've already got in the market now. So we kind of need to start working on this now and getting something ready to go for when, the crude oil prices increase, demand drops or supply drops. We're expecting that we'll be paying a lot more for bitumen in the future. So we need something we can actually offset this and replace it and decouple ourselves from using crude oil. Next slide, please, Doi. So what is BioBind? So BioBind is a complete bitumen replacement. It doesn't rely on the refining of petroleum. Currently, in the Generation 1 version, it's derived from about 70% renewable sources. We're not cutting down trees to produce this as a waste product from the pulp and paper industry. It's locally sourced. So we're not importing it from Europe or the States. It's locally sourced in New Zealand at the moment. And the manufacturing process is one that's been developed by Road Science in-house. So it's it's locally produced and locally manufactured as well. In terms of binder performance, I guess the key thing for us was we were trying to make sure that it met the local specifications, rather than trying to do anything too radical there, where we're trying to redevelop how we make roads. So on the previous slide there, you would notice that we've got something that conforms to all of the Australian bitumen specifications. If you go back to maybe the previous slide there, Doi, you can? Yeah, this one here. So this just showcases, I guess, the binder properties that we produce by making this material. Conforms to the AS 2008 specification. In this case, I'm going to show you a bit of a trial we recently completed, but the binder we were producing at the time was pretty close to actually conformed to a class 600 according to the local Australian specification. So it met every requirement there. So we can make something, we can make any grade we want, but the key thing here is that we can make something that meets current local bitumen specifications. So we're not having to go and really change processes or design processes. This fits right into our existing mixed design and application processes. In terms of asphalt performance, it's essentially gives us very similar performance in terms of rut resistance. There's two tests we focus on in terms of looking at how it performs in terms of when it goes into an asphalt mix. One of them being rut resistant, so that's essentially having a loaded wheel pass over the mix we've created, and measuring how deep that deformation occurs over time. So the higher the result there, the worse performing it is. We took the same asphalt mix design and just replaced the binder and compared performance. In terms of standard bitumen, so this would be again a class 600 we'll be comparing it against. We've got a rut depth of around about 4.5 mils. When we just replaced the biobind straight into that same mix design, we saw a reduction in rut resistance, went down pretty close to 3 mils. So we saw a slight improvement there. In terms of fatigue resistance, so I kind of consider fatigue resistance to be, I call it the plastic ruler test. So you think about if you're at high school, you had a plastic ruler sitting there a bit bored in class, you bend it a few many times, this thing snaps. We kind of test the same thing with asphalt. So you think about it, if you put a layer of asphalt down on the road, vehicle's going to drive over top of it, it's going to flex that layer of asphalt, and eventually it will start to crack and break. So what we're trying to measure there is how many times can we flex that layer of asphalt before it starts to crack, essentially. On the right-hand side there, you can see, again, the comparison between standard bitumen and the biobind. Standard bitumen lasted about 300,000 cycles before it started to crack. In terms of biobind, we're getting up to 900,000 cycles. So it's quite a significant improvement in terms of fatigue resistance, and it's a good measure of, I guess, the durability of that asphalt mix. So I guess the conclusion for this slide really is that biobind is less likely to fail due to rutting and fatigue. In terms of carbon emissions,
so I'm not sure why I keep skipping. There we go.
That's all right. Obviously, it's something we're still working on to finalise and get a proper EPD sorted. Based on our initial internal analysis, for a ton of biobind would offset roughly around 2 to 3 tons of bitumen. So one of the key things in here, we're trying to pick raw materials that act like carbon sequestering agents, where it actually captures carbon through the growth of that plant material. And then we're using that waste to actually produce our binder. So these were subject to change, but just to give you a rough idea of where we're sitting in terms of reduction in carbon emissions, it's roughly around, we'll be offsetting 2 to 3 tons of bitumen for every ton of biobind we use. Obviously, it's being a very new material. There's also some health and safety concerns that go along with it. We have completed leachate and fume testing with it. And I guess the key thing for the Road Science brand is about, we've got some really smart people who can develop materials. but we also have some really smart people that can grow and implement these materials into the field and actually test how they work in reality. So we recently conducted a full-scale trial using this material. And we get the opportunity there to capture the fume testing data. So we've got a vacuum pump there just set up at some really key high-risk points within the process. So one's on the cycling belt at the asphalt plant. Another point we took was right on top of the bitumen tank at the asphalt plant, where there's people very rarely go, but there's probably where the highest concentration of fumes are. And we also had it set up at the back of the paver as the asphalt's coming out of the back of the paver. So probably really, I guess, the worst case scenario in terms of exposure to fumes. If you just click once, there's this. So this one here is just the results of that fume testing. So we've scanned for every possible thing that will be coming off these fumes. What we've got listed here are the things that it was managed to detect, and we compared that to the safe, I guess, the workplace exposure standards. So key thing here is if it's above 100%, it's considered dangerous. If we're below 100%, it's safe. So what we could see here are all the things we could detect. Some of them were well below the detection limits, but the highest one there we could see was at 15%. So still much lower than the workplace exposure standard. So we can consider this to be quite safe, and probably in some cases probably a little bit better than bitumen as well. So once we'd satisfied ourselves about the fume testing, and also the leachates gave us the same results, there was nothing coming off. In that sense, we were able to take it to a full-scale trial. So it's just in October of this year. It was only a couple of months ago. We were able to go pave a section of road in New Plymouth in New Zealand. And in terms of just testing this out and making sure that, hey, what we've developed in the lab and what we're seeing in the lab is going to be replicated in the field. And this gives us the opportunity as well to monitor the site. So, like I said before, we want to get using this material. So then when we have to make the change, we've got some really good data sets there to be able to prove that, what we're doing at the moment is the right thing to be doing long term. So this section of road has about 20,000 vehicles per day on it, and about 4% of that are heavy vehicles. So it was a good test for it. In this case, we're just replacing the top 50 mils of the asphalt. So it's kind of considered to be a thin surfacing. Go to the next one there, Doi. Yes.
Oh.
I guess the feedback we had from the crew and the QA results was that it just behaved like standard asphalt. We've managed to meet the same bitumen performance criteria. So when the team were putting it through the asphalt, laying and compacting it, they couldn't really tell the difference between standard bitumen. The only thing they raised was that it smelled different. If these guys are working with this every day, they can pick up any small changes as well. So it certainly smells different, but everything else behaved like a standard asphalt. In terms of, I guess, next steps for us, we've got this one site down where we'll be monitoring its performance over the next few years. So we've got a good set of teams that can do the data collection on it. So looking at any kind of defects, rutting, texture, skid resistance, we can do the full suite of this to actually understand how it behaves over time. We're not expecting it to be any different to a standard asphalt from the work we've done so far, but we will be monitoring that. And it's just to sum up, obviously it's a complete bitumen replacement, but we can also use it in conjunction with other binders. So it's compatible with standard bitumen, so we can dilute it back with standard bitumen if required. So it fits very easily into our existing processes. And the fact that it conforms to both asphalt and bitumen specifications, it doesn't really require much exchange in terms of standards or anything like that. We can just slot it straight into our existing design processes. But the key thing I just wanted to raise for this is that we're really looking to start this transition now and move away from using these crude ore sources for our as our major material in our construction processes. So we're really looking for anyone here that's keen to give this a go and get on board now, where we can actually start moving forward with this type of technology and get it ingrained into our normal processes. So when we're more prepared for when, hey, eventually we're going to have to move away from crude ore sources. So then everyone will be ready and I guess willing to move forward with minimal disruption. So thank you for your attention. I'm happy to answer any questions.
Thank you. Apologies, I'm not sure why the slides were skipping, but obviously, Andrew, this is firmly in your wheelhouse. Over to you.
I had to go first. Yeah, thanks, Darcy, for the presentation. Just you spoke about 100% bitumen replacement. So it's not a bitumen. It doesn't contain bitumen. Is that
no bitumen in this one?
No bitumen at all. Okay, that's very interesting. And it meets you said it meets AS 2008. It's compliant.
Yeah.
Okay. So the product is manufactured in New Zealand. What's the proposal in terms of supply to here or manufacturing in Victoria, Australia?
Yeah, I guess we are able to supply out of New Zealand. We've got the pilot plant in there. I guess obviously as we build scale and demand, there's no reason why we couldn't set one up in Australia as well. I guess the current proposal would be for anyone who's interested will be supplied in bituteners, so you'll be in kind of 20-ton lots, which will probably make, let's say, if you're making asphalt, you'll be about 700 odd tons of asphalt or more, depending on how much wrap you combine with that as well. So certainly we could bring that across. I guess the coastal shipping is a relatively efficient way of doing it. I'd have to get some exact numbers on that, but I wouldn't expect it to be a huge increase in cost by shipping it out of New Zealand with that coastal shipping option.
Right, and it's derived from a waste product from the tree sector, tree industry.
Yeah. I guess we've always tried to make this process as agnostic of raw materials, so we're always on the lookout for other options, and there's a few sources in Australia we're looking at as well, whether we could use some local Australian-based sources too. So it was one of the key things through the development was like we're not going to be tied to just one source of waste material. We want to make sure we're able to make from other waste sources as well, so we can grow that scale and with demand.
Right. Last question. Asphalt's 100% recyclable. So what do you see is that is this product recyclable?
Yeah, we expect this to just behave just as a normal asphalt, where we could recycle it, 100%, and no issues there in terms of anything strange or that we wouldn't be able to recycle. So we consider it just to be 100% recyclable.
Thanks, Darcy. Very interesting stuff.
Thank you.
Thank you. Irina.
Thanks, Doi, and thanks, Darcy. I totally agree that we should be thinking of transitioning as soon as possible, I guess, to materials like this one. My question, and maybe it's already answered by the testing that you've done for fatigue and the cracking. I just wanted to know how will this product perform, if anything, in a highly reactive soils. Like is the flexibility going to be affected, and kind of the performance for crack resistance and everything else?
Yeah, I guess that's probably governed by the asphalt design process. So I guess anything there that would be unusual for a normal asphalt would remain so for the use of this product. But I couldn't answer that one. But we could look at it in terms of putting it through our design process to understand that a bit better as well.
Obviously, it's very promising that for fatigue, I guess the resistance, you got like almost like 3 times the better performance, I guess.
Yeah.
So, all right. Well, that was my only question. Thank you.
Thanks, Irina. Numan, any questions from a rail perspective?
Nothing specific from a rail perspective. It's a very nice product. Darcy, thanks for sharing. One thing I was just thinking was about if there's any impacts on the properties as to how the pavement then reacts to water.
No, it's pretty much very, very similar to what we've experienced with standard bitumen. So, long-term exposure between water and asphalt's never great for it. But we expect this product to give you the same performance as what we'd expect to a standard bitumen.
And in your testing, when you're trialing it, is that something that will be further investigated essentially? Yeah,
well, it's through the asphalt design process. There are some moisture susceptibility testing in there.
All right.
And it gives conforming results in that one as well.
All right, perfect. Thank you.
Fantastic, thank you. So What we've done, Darcy, because our last presenter has the least amount of time to answer questions from the audience, I thought we'll ask some of these questions live. So Darcy, feel free, you can hop into the Q&A or I can read them out to you. I might kick off first questions from Rod Pomeroy. There are generally 3 key grades, 170, 320, and multigrade bitumens. Is BioBind able to offer the 3 different viscosity? Secondly, how does it achieve the 10-day durability test?
Yep. So we can easily just change the grade. The one particular one we used was class 600, but it's quite easy for us to scale that back. And typically, generally the harder we have to go, the more expensive it becomes. So we've gone for the hardest possible option with the class 600, so we can easily come back from that as well. In terms of your question around the 10-day durability test, we'll just need to, we haven't done that for the Australian market yet. We've done it for the New Zealand market for their durability test. So it certainly conforms to that very easily. So I don't anticipate it to be an issue, but that's one thing that we haven't confirmed yet for the Australian market, but I don't anticipate it to be a problem.
Thank you, Darcy. A lot of questions here, obviously a lot of road engineers in the audience. This question is from Steve Halligan. With regard to fatigue cracking, is the improvement coming from the biomaterial or the approximate 30% petroleum sourced material?
I'd say it's probably the biomaterial there. It does it is essentially is based properly as an oil. So certainly, normally if we put any oil into any kind of binder, it does significantly improve the fatigue resistance. I'd say most of it's coming from that.
Right. Another question from Rod Pomeroy. In manufacturing the BioBind, can you use the stumps and trash from harvesting to make the product, which generally represents about 20% of the tree effectively wasted?
Yeah, we're probably not at that point yet. I know there's a few other groups looking at how they can reuse some of that slash. I think they're a little way off being able to do that just yet, just because the greatest cost in doing that is actually collecting it all. So we're not at that point yet. We're mostly drawing from, I guess, people have drawn all their usable products. If you talk pulp and paper, they've taken one of the waste materials from there, drawn off all the higher value products from there. We're left with the waste material from there. So there's other people that have further up the process than us that'll be interested in that part, but not necessarily us.
Great. This question is from Hamadreza. Is BioBind a PMB or a neat binder?
It's currently a neat binder. We could potentially make it into a PMB. We ran with the neat binder to start with, but there's no reason why we couldn't do the PMB option as well.
Thank you. Question from Theo. What is the impact on cost of purchasing BioBind as compared to C600 binder? Has a cost-benefit analysis been undertaken to provide a relative return on investment period? Will the product transport similar to standard binders? 3 questions there in one.
Yeah. Okay. I'll start with the transportation one. Yes, it stores and transport the same way as what we would for a standard binder, so that's not an issue. In terms of the cost benefit, we haven't conducted that yet, but we don't expect it to be any different in terms of lifespan. The cost of the binder relative to this class 600, it's relative to how far you want to go in terms of bitumen replacement. So the complete bitumen replacement, obviously it's in a pilot plant stage at the moment. We're probably looking at kind of two times the cost of the standard binder. But we're also conscious that that's not appropriate for everyone. So that's why I mentioned at the end there we can dilute it back with standard binders as well to get it back to I guess the cost point that people will feel more comfortable with. I guess that comes at a detriment to your carbon savings as well. So I think the thing I like about this, it gives us the ability to scale it with the cost versus the carbon savings and find that sweet spot for the customer as well, where they can choose at what point they feel most comfortable with. And we've got people there that want to go complete bitumen replacement. That's at the higher end of the scale. There's other people who'll go for, hey, I just want a partial bitumen replacement and capture some carbon savings there. So we can certainly scale it right back to something that everyone's comfortable with.
Thank you. I think you've answered the next question there as well. I might move on just in interest of time. A question from David. Does BioBind oxidize differently to, say, C170 bitumen? Does it give preference for binders in asphalt surfaces where aging or binder hardening rather than rutting or fatigue is the main form of distress? And adding to that, is it susceptible to damage from oil or fuel spills?
Yeah, yep. So in terms of oxidation, it's very similar. Like basing it on the New Zealand specifications at the moment. So, but yeah, in terms of oxidation and long-term durability, we don't see any difference. It's probably slightly better than standard bitumen from what I've seen. But we'll confirm that with the Australian long-term durability testing as well. In terms of is it susceptible to oil spills, it'll be just the same as bitumen. So anything that can degrade bitumen, any kind of petroleum-based products there, it will have the same effect on it. So it doesn't offer any benefits over and above standard bitumen in that case.
Fantastic. And I might combine the last few questions. There's a question here about consideration to leachates in the environment if the bitumen breaks down over time, along with aging studies.
Yep. Yeah, so in terms of leachates, we have done some leachate testing. I didn't put it up there because we couldn't actually detect anything. But we're looking for similar things, what we're seeing with the fumes. We can pull that together as well and provide that, but it was all nothing. So we haven't seen anything undue come out of that. In terms of, sorry, can you repeat, what was the last part?
Any aging studies carried out on
aging studies? Yeah, I mean, we have done it on the just the standard durability testing. So that's under the PAV. We haven't done anything with, I guess, UV or long-term weathering, but that's something we can certainly look at. But again, I don't expect it to be any different to standard bitumen, to be honest.
Right. And last question from Priya: is the bio-waste source for BioBinder from plantation forests?
So yeah, we're not cutting down trees specifically to make BioBind. It is obviously anything coming from pulp paper would have been from a tree source, but generally that's reusing other materials throughout the process. So we're just essentially an offshoot of an existing process there. Creating pulp and paper at the moment. We're using a waste material that's just been derived from that. So we're not specifically chopping down trees just to make this product.
Fantastic. Thank you. And I might cap it there. So Darcy, I know that when we caught up about BioBind, obviously the next steps is either to make it here in Australia, or if there's the appetite to perhaps even trial with a batch that we can bring over from New Zealand. So any road projects out there keen on pursuing innovation, I think BioBind seems to be a really viable alternative to our reliance on bitumen. So Darcy, thank you for that presentation. I'll now bring this event to a close. A lot of questions there from the audience there. Thank you for coming out today to our last showcase for 2023. Again, I said at the start that this is all a call to action. So it's not just about information sharing. If we've inspired you to look at some of these products and pursue, that taking the next step and moving the dial forward with industry and how we build road, use concrete, how we upcycle, recycle, end-of-life solar panels, or really what we can do with textiles, probably one of the biggest elephants in the room when it comes to persistent waste problems. Please reach out to us. So we have a knowledge hub. If you've enjoyed these online series, next year we'll be kicking off with a series of masterclasses and similar content that we'll provide out to you. And like all things today, the fastest way to find out what's happening is to actually follow us on LinkedIn. So ecologiQ's on LinkedIn as well. So jump on the socials. If you see something, please like, share, and subscribe, and join us on LinkedIn. I'd like to thank our panelists and presenters again for sharing what they're doing in terms of innovation and their time and expertise to give our industry partners some feedback. So thank you for coming along to the showcase again, and I wish you all a safe festive season, and we'll see you in 2024. Thank you, everyone.
Thank you.
Thanks, everyone.
Thank you.
Thank you.